Okay, students, what is the question number 7? Fastly. By using the properties of determinant, show that the question is determinant of a square, sorry, minus a square, ab, ac. Then the second row is ba minus b square, bc, and this is ca, cb minus c square. Am I right? So this is equal to, we have to show that 4 a square, b square, c square. So this is the question, right? So how can you show that the this determinant value is equal to 4 a square, b square, c square? So it is very easy, right? So what will you do? Can you expand directly? If you expand directly also, you'll get the answer. But instead of that, you have to use the properties. Properties. First, we have to apply the properties. Then, at last, we can expand the given determinant. Don't expand directly. Okay. So, what is the property we can use? So, is there any common or row wise or column wise? Anyone? Is there any common row wise? Yes, in first row.
A,
A is common. Is there any common in second row?
B,
Yeah, I'm taking LHS. In that LHS, first I'm taking A, B. In third row, C is common. When I take these values, the remaining value is minus A, B, C, right? Then here, A minus B, C. If I take C common, A here, B here, minus C. Am I right? Am I right? Is it clear? Okay, fine. I have taken A, B, C. A from first row, B from second row, C from third row. So remaining, this is the determinant. Again, if you see the determinant, again anything is common. Yes.
A, B, C from column.
Again A, B, C. Okay, column wise. So don't think about always we should take the common row wise. Not like that. So even we can take common column wise also. So A, B, C already is there. Again, what is the common column wise? A is common. Second column, B is common. Third column, C is common. So this is remaining value is minus 1, 1, 1. So 1 minus 1, 1, 1, 1 minus 1, right? So this is clearly a square, b square, c square. Now also you should not expand directly. So you can apply some transformations. Okay, I want to apply here. Here I want to apply R1, R2, R2 minus R2 plus R1. It's better. So R2 tends to R2 plus. When you adding this element becomes 0. In the same way, R3 tends to R3 plus R1. Is it clear? Minus 1 plus 1 again 0. So I want to make them these two values 0. I want to make them these two values are 0. Adding, I'm adding. So then finally, your LHS, what is A square, B square, C square? ABC into ABC. So A square, B square, C square, the remaining value after applying this operations, then first row remains the same. I am applying the operation on R2 and R3. So R2, this is 0, this is 0. Okay, to make them these two values 0 only, I apply this. Then R2 plus R1, R2 plus R1, again this is also 0. R2 plus R1, 2. Then R3 plus R1, 1 minus 1, 0, 1, 1, this is 2. And minus 1 plus 1, this is also 0. Okay, finally we got like this. Then what to do next? Anyone? Now you can expand. So I want to expand column wise. Here plus, minus, plus. Whenever you want to expand, you have to give the sign plus, minus, plus. I want to take column wise because second element, third element will be 0 column wise. Okay, just you need to find the minor of this minus 1 alone. That's it. So look at here. So this is equal to a square, b square, c square. So into bracket minus 1 into the minor. Okay. What is it? 0, 2, 2, 0. Then what about remaining? Minus 0 into anything will be 0. At last plus 0 into anything will becomes 0. Okay. So finally it will be 0. 0 into anything 0. So no need to write this. So finally here a square, b square, c square. So what about here? Minus 1 into mine. This is minus. Okay, now AD minus BC 0 minus 4. So finally minus into minus plus 4a square, b square, c square. Is it clear? So you should write each and every step in NCRT. Okay, so but the same question they given in board level like OBT. What to do? Is there any shortcut method? Yes, shortcut method is there. Simply you can give a is equal to b is equal to c is equal to 1. That's it. A is equal to 1, b is equal to 1, c is equal to 1. So what about the determinant? Minus 1, 1, 1. Like we will get like this. We get like this. Now the same a is equal to 1, b is equal to 1, c is equal to 1. Substitute in RHS also. RHS value 4. RHS value 4. Let us see LHS also 4 or not. Obviously it will be 4. Okay, like that you have to do. Don't expand in OBT, JE. Simple. Substitute A, B, C values. Otherwise, do one thing. Substitute A value 0, B value 0, LHS 0, RHS also 0. It's depending on the question. Better to give non-zero values. Okay.
So this is new lesson, sir.
It is a determinant.
Okay, sir.
Determinant, I am discussing NCRT. This is a deleted exercise last year. Okay. Anyhow, this year might be they give later. This is deleted. Anyhow, we will complete this. Okay. What about the next question? Anyone? Yeah. Next question is what? Question number 8. Having any doubts, you can ask. Yeah, eighth question. Okay, in eighth question, how many there? There are two subdivisions are there. Okay, what is the first subdivision? Your wish, whether we'll do the first one or second one. Both are easy only. Okay, so right, let us see the first one. They given 1, 1, 1, and after that ABC, ABC, A square, B square, C square. This is the first subdivision. Coming to the second subdivision, they given like 1, 1, 1 first column, but second subdivision they given 1, 1 as a row, and here A B C they given column wise. In second subdivision they given row wise. Okay, A square, B square, C square column wise, but they given row wise. So you should not think that in both the cases will get the same answer. Not like that. The second subdivision is whatever the column is given, they're given as row. That is second subdivision. If it is matrix, okay. Right, now. So how can you show that this is equal to, we can show that A minus B, B minus C, C minus A. Is it difficult? Not at all difficult, right? So first, Yarish, what to do? You can use any one of the element. You can make them remaining value 0. So if you see right side, so it is A minus B is there. A minus B is there. For that, what to do? A minus B, B minus C. Shall I do like this? A minus B, nothing but R1 tends to R1 minus R2. Okay, A minus B will get like this. A minus B. Okay, next B minus C is there. B minus C. Shall I write R2 tends to R2 minus R3? Yeah, we can write. We can write. Okay. And shall I write one more condition also? We can write, but not necessary. Just first apply these two operations. Okay. When we apply, so I'm taking LHS and LHS becomes what? So one here 1 minus 1 0 0 and here it is sorry, R1 tends to R2, right? A minus B, here A square minus B square. R3 remains same. R3 1 C square C C square. Okay, here again finally C minus A is there. Don't apply that operation. So you may get doubt, sir. Sir, why don't we take again one more operation? R3 tends to R3 minus R1. If you take like that, what will happen here? Yes, what will happen? This element becomes 0. Here also it will become 0. You may get like a C minus A C square minus A square, but all becomes 0. So one entire column is 0, the determinant 0. But right side we have to prove that A minus B, B minus C, C minus A. Okay. Right. Now, see, I applied this operation R1 minus R2. Then R2 minus R3. So R3 is same 1 C C square. So here 0, 1 minus 1 and B minus C, B minus C, B square minus C square. Next, what to do? Yeah. Is there any common row wise in first row? See, A square minus B square can be written as A minus B into A plus B. Am I right? A minus B to A plus B. So take A minus B common. So A minus B. In second row, is there any common? Yes. B square minus C square can be written as B minus C into B plus C. Then B minus C is common. Then the first row, second row becomes 0, 1, A plus B. 0, 1, B plus C. 1 C C square. 1 C C square. Okay, now you can expand. Now you can expand the determinant. Is it clear? Now you can expand. So whenever you want to expand, okay, what column or what row you want to use here? Which is better to expand? To first row wise, the second row wise, third row wise, or first column wise, second column or third column? Anyone?
First
Yes.
column. First
Yes.
column.
First column, wonderful. Because you can apply any row, you can use any row or any column, you get the same answer. The thing is, if you use first column, what will happen? Plus, here I said plus minus plus. If 0 into anything, 0, 0 into anything, 0. So plus 1 other than this row column, this determinant of this value. Okay. So like that you can take. So this is equal to 0 into some determinant minus 0 into some determinant. At last plus 1 into the determinant. Before that what? Before that A minus B, B minus C is there. Okay. In NCERT you should write these 4 values. Anyhow the value is 0. But you should write this 2 by 2 submatrix, right? Now here what? Plus 1. Right? Plus 1 is there. Yeah. 1 1 1 1. Yeah. A plus B, B plus C. That's it. Now AD minus BC. So this is A minus B, B minus C into AD minus BC. So B plus C minus A minus B. Am I right? AD, AD minus BC, minus A minus B. Anything cancel? Yeah, get this cancel. So this is equal to what? A minus B, B minus C, C minus A. That's it. So this is the required RHS. That is the required RHS. So note it down. Getting any doubts, you can ask. So first, don't expand directly. Try to apply. We may do like this generally. If they don't mention like using the properties of determinant, you have to expand this. Okay. Sometimes we unable to make them in the form of A minus B, B minus C minus A. So take LHS, you can expand. This RHS, you can take multiply. A minus B into B minus C into C minus A, you can multiply. Finally, anyhow, we'll get LHS equal to RHS. But clearly they mention here using the properties. I use the properties. I'm taking some column, like row operations I use. Okay, I've taken common outside like that.
Sir, one doubt, sir.
Yeah.
Sir, for first row you took A minus C as common, sir. For second row you took B minus C as common, sir. How can we take common for one row alone, sir, instead of the whole matrix?
So instead of one row, how can we take the common? That's your. It is not common for all the elements, but we have taken the common. That is your doubt. Am I right? Okay. First row. Shall I write here 0 is 0 into A minus B?
Yes, sir.
Yeah. Here A square minus B square. Shall I write A minus B into A plus B? What is the common entire row?
A minus B, sir.
Yeah, A minus B have taken common, but determinant, you should remember that. So whatever the common you are taking, that is belongs to only either row or column. It should not belongs to entire determinant. Entire determinant. Okay. For
Okay.
example, something is there, like A will be there, A will be there, A will be there, A will be there, A, and here also A will be there. So when you see this, so it's looking like A is common for all the elements. How can you take A common? If you take A common, okay, can you take only A common? A is common for each and every element. You should not write A outside. You should write A is common first row, second row, third row. 3 rows are there. So it will becomes A cube. Or you can take column wise also. A cube. Finally, you'll get A cube, not A. In matrix, it must be common to each and every element. Whereas matrix, in determinant, not like that. Okay.
Sir, but if we take row once, we should always take row only, sir, for the determinant. We
If
should
you
not
take
take all.
If we take a common row wise, we should take row operation, you are saying.
So if we take row option, we cannot take column, sir. I'm asking, sir.
Um, yeah, that only in determinant we can do in many ways. Many ways we can do that. So I
Okay.
have done in this way. You may use a column operation, but it is not possible to get A minus B, B minus C, C minus A by using column operations.
Okay, sir, got it.
You can try that second subdivision. Yes. Shall we do the ninth one? See, this concept is you have to practice one or twice. You must be practice one or twice. It's not at all difficult. It's no need to like how to what are the operations we need to operate. That only you should have idea. So my suggestion is you can practice this exercise at last. Okay. If for online classes are continuing like that, definitely again they'll give last year syllabus. Surely. If there is any offline classes, they'll give fully portion. Otherwise, they'll give 70% of the portion alone. Okay, students, can you try the remaining, or else if you're having any doubts, any question you can ask, that we will do. First, try yourself. I told you, we planned uh, at last we want to discuss this deleted portion. But anyhow, we are discussing. We planned like that all not teaching yet teaching. Total how many questions are there? 15. Am I right? Yeah. Can anyone say that answer for the 15th question? Which one of the option is right for the 15th question? Yes. Question number 15. It's depending on the property Ka. So A is a matrix of order 3 by 3. If we take K outside, that is we get K cube into det A. That is property directly. Okay. Okay, all OPT students listen. Yesterday I didn't take due to some other work, other meeting. Okay, and today I can continue the class. We're having up to 3 o'clock classes, 3:10 to 4 OBT class. Okay, if I said any other time like evening, I'm getting some other works, right? Okay, ma. Right. So you can try the remaining questions. If they didn't delete this exercise, at last once again we will discuss this exercise. We'll do all the problems again. Right. Next, I'm going to start second chapter, not first chapter, second chapter. That is inverse trigonometric functions. Okay. So as for the master's G schedule, they given after matrices and determinant inverse trigonometric functions. So that I am starting. After that, we'll go for the chapter 1. Okay. So the first 1 or 2 classes are very important. Okay, the inverse trigonometric functions will play very important role in calculus. Very important role in calculus. That is maybe differentiation, maybe integration. Both the cases. So to understand the inverse trigonometric function, so you should know each and every concept about trigonometry. Okay. So without knowing the trigonometry, sometimes we may not be understand the inverse trigonometry. Okay. So in science and engineering also we can apply this inverse trigonometry. Okay. So mainly this is very important for calculus. Fine. So let us see the inverse trigonometric functions. There are 6 trigonometric functions are there. Sin x, cos x, tan x, secant, totally 6. So in the same way, there are 6 inverse trigonometric functions are there. One is sin inverse x, cos inverse, tan inverse, secant inverse, cosecant inverse, cot inverse. Finally, 6 inverse trigonometric functions. So what is important? What is important from trigonometry? So to understand the inverse trigonometry, you should know about the domain and range. Domain and range of the trigonometric functions. We are saying that trigonometric functions. Trigonometric functions. Okay, inverse. When the inverse is exist, that is very important. So when the function is 1, 1 and on 2, when the function is 1, 1 and on 2, then only inverse is existed. So what is the mean by 1, 1? 1, 1 means, so distinct element of the domain having distinct images. Okay, once again I am telling you that 1, 1. Okay, NCERT concept only. So the distinct element of the domain having distinct images in codomain, then that is 1 1, right? And coming to the onto, that we know that onto means the range is equal to codomain. Range is equal to codomain. So nothing but each and every element of domain must have pre-images, must have pre-images. Okay, that is called onto. So mathematically we can use some other formula. So x1 is equal to sorry, f of x1 is equal to f of x2, which implies x1 is equal to x2. Then we can say 1 1, that was mathematically. But you should remember that what is the mean by 1 1? Distinct element having distinct images. 1 1, each and every element of codomain having pre-image. Okay, pre-image, then that is onto, or range is equal to codomain. Fine. So when the function is 1 1 and onto, then inverse is exist, because it is bisective. Whenever it is bisective, inverse exists. The inverse function also must be 1 1 and onto. Fine. So if you see here, f is a mapping, f is a mapping from, f is a mapping from a to b. A to b, here if I take x is any element in domain, y is any other element in codomain. Simple. So f is the image of f, x with respect to f. So which implies it can be written as f of x is equal to y. F of x is equal to y. I'm going to take another function or another mapping like g. G is a mapping from again B to A. B to A I'm taking. So B having Y, A having X. So G is a mapping from B to A. How can you write here? G, image. Okay, image of Y. So with respect to G is equal to X. We can write like this. We can easily write like this. So F is a mapping from A to B. So that can be defined as F of X is equal to Y. Okay, G is a mapping from B to A. So it can be represented like G of Y is equal to X. So here Y is belongs to domain. So what you observe here, the domain of F is A, codomain is B, domain of G is B, codomain is A, opposite, reverse. Okay, so what are the functions I have written? If Y is equal to F of X is equal to G of Y. Y is equal to F of X is equal to G of Y. Nothing but, yeah, this is G from B to A. This is F from A to B, F from C. This arrow symbol is very important. The function defined from where to where. So arrow will represent like this, nothing but domain to codomain. Input is domain, the output is codomain. Output will be codomain. That is called range. Okay, fine. So if I multiply these two functions, what will happen? F of G into Y is equal to what? So this is equal to Y we will get. That is equal to Y we will get. Okay, so f of G nothing but F circle G of Y, F circle G of Y, or G circle F of X, F of X I said. So the meaning is, if I take any two functions, like first will be F. First function, don't take like, so F of X nothing but this is a variable. It will start with F. Okay, F from A to B. G, next to G, next to G. So G is approach to F. F of X nothing but first we can take the function F. F is always A to B. Next will be G. Next will be G. Okay, first F, next to G. G from where to where? Here, G from A to B. Finally, what about G circle F from A to A? A to A. So actually, this is the concept of chapter 1. In chapter 1, again, the last year, we are having up to first two exercises. This composite functions and inverse function, they deleted. Third exercise, fourth exercise, they deleted last time. So we don't want to neglect. So we will discuss third exercise, fourth exercises also. So this is the concept about third exercise, like fourth exercise, composite functions. That inverse function is third exercise. I think third and third exercise both. Okay, conjugate, composite functions and inverse. Okay, anyhow, finally, G circle F means it will starting with A, ending with A to A. A to A. X is Y, X. So if we give input, what is the output? Again X. If you give the input, output also same. So nothing but what? G circle F. Input I am giving X, output finally we get X. So X is mapping to Y, Y is mapping to X. Finally, input X, output also X. So this is also called identity function. Identity function. Identity function, always remember that function having domain and codomain. Identity function must have domain is same, codomain is same. So A to A, identity function can define from either if you take the domain is A, codomain must be A. If you take the domain is B, codomain also must be B. So identity function defined from A to A or B to B like that. So whatever the input we are giving, we getting same output, then that is called identity function. Clear? Identity means identity. So like in matrices we have seen that, so any matrix multiply with identity matrix, again we get the same matrix. So whatever the input you can give, input whatever you give, output also same. So f g circle f of x. So f of x, look at here, f of x. I'm giving input is x, output also x. Output also x. If I take the another composite function like this, okay, so f circle g of y is equal to what? Is equal to what? First we should take g function. Here g of y. Nothing but g is a function mapping from b to a. This is g. It will approach to f. So next f is a mapping from a to b. So what is the input I'm giving? Y. So already we know that g of y value is what? G of y value is x. So g of y is equal to x. Since we know that, since we know that f is mapping from a to b, f of x is equal to what? Y. So finally, what do you observe here? So whatever the input we are giving, we are getting the same output. So when it is possible, nothing but both the function must be inverse to each other. So when I take like this, if f and g will be cancelled, we get y. In that case only it is possible. So here f circle g or g circle f. So if here it is g circle f, x is equal to x. When it is possible, when f and g are inverse to each other, then only whatever the input you are giving, we are getting the same output. Is it clear? Okay. So here f and g are inverse to each other. F is mapping from a to b, g is mapping from b to a. F and g are inverse. Then how can you represent like so I'm saying that here f and g are inverse, so it can be written as g is equal to f inverse. G is equal to f inverse or f is equal to g inverse. Any one of the way you can represent. You can represent any one of the way. So g is the inverse of f and f is g inverse of g. Any one of the way we can write. And so in case if you write, what will happen? G value substitute here. So f into f inverse of x. So get cancel, again that is equal to x. Okay, fine. So this is a concept about the inverse of a function and composite functions. So once again we'll discuss this concept in functions. But see, we are starting inverse trigonometric functions, so you should have idea. So the domain of the function becomes codomain in inverse. Okay, so remember that f is a function from a to b, f inverse must be from b to a. This you have to remember. F is a given function, then its inverse is from b to a. So domain becomes codomain, codomain becomes domain. That's it. That point you have to keep in your mind. So the same concept we can apply to the inverse trigonometry also for trigonometric functions. Fine. So first the graphical representation. So before that, if you want to draw the graph of trigonometric functions, you should know about domain and range. Okay. So especially, so NCRT student and JE student must be remember domain and range of the sine function. Then we can easily do that inverse functions. Inverse functions. Okay, right? Okay, fine. First, Let us discuss about trigonometric functions. How many trigonometric functions are there? 6. What are that? First one is sin x. Sin x. I'm going to write domain and range. Domain and range. So let us write now domain and range. So what is the domain of sin x? Anyone can remember? What is the domain? Real number. What is the range? Range nothing but what is the maximum value of sin x? What is the minimum value of sin x?
Minus
Okay,
1 to
minus 1 to 1, right? 3 o'clock. అవసరం కదా మరి ఎలా మధ్యలో ఉన్నాను నేను ఒకసారి మౌలం సార్ రమ్మని చెప్పి అవుతాను మరి సెట్ చేస్తాడు క్లాస్ మధ్యలో ఉన్నాను ఓకే స్టూడెంట్స్ రైట్ sin x is r domain is r range is minus 1 to 1 and second one is cos x. Cos x also same domain is real number and minus 1 comma 1 and clearly tan x everyone should note it down. Okay, domain is what here? Anyone? Okay, what is the value of tan 90? Tan 90
infinity.
Infinity nothing but if you see that trigonometric table, so clearly they will give the not defined or undefined. The meaning is at 90 the tan is undefined. Not only 90, what is tan 270? Yes, tan 270
Undefined.
undefined. Okay, so your 270, like you can add like 180 every value, like 90 plus 180, 180 was 270, 270 plus 180, 450. Like for every value it will becomes undefined. It may be plus or it may be minus. Plus infinity, minus infinity, because you know sin tan 90, that you know very well, it can be written as sin 90 by cos 90. So 1 by 0, that is infinity. 1 by 0, that is infinity. Am I right? Not defined generally. So at where for tan of which value is infinity? It's the curve which move to infinite. The curve which move to infinite. So nothing but we can say undefined. We cannot draw the graph to infinity. So in that case, we can remove these values, like other than this value. So for remaining all values, it will be finite. It will be defined. So nothing but till tan 89 point, like 89.999, it will be defined. At 90, it will tends to directly infinity. So that other than 90, 270, uh, not only plus 90, tan even minus 90 also becomes minus infinity. It may be plus infinity, it may be minus infinity. Remember that it is undefined. Can you able to draw the graph up to infinite? No. Right. So in that case, other than 90, so how can you write generally? So if I write 2n plus 1 pi by 2, 2n is equal to 0, pi by 2, 90. N is equal to 1, 3 pi by 2. N is equal to 2, 5 pi by 2. Anyhow, pi by 2 will be there. Whenever pi by 2 is there, then clear it is infinity, plus or minus infinity, undefined. So that I want to remove this. Here n is belongs to z. Substitute n value may be positive integer or negative integer. Like look at here. So here domain is other than that value. So r minus 2n plus 1 into pi by 2, n belongs to z. N belongs to z. N belongs to z. Am I right? Now, so what is the range? What is the range? Yes, anyone?
Minus infinity.
Minus infinity to
Infinity.
plus infinity. Nothing but what? Real number. Am I right? R? Yes. So in the same way, what about fourth one? Like cot x. Cot x nothing but cos by sine. Cos x by sine x, for what value of x? Sine becomes 0. Yes. Sine 0, 0. Sine 180, 0. Sine 360, 0. Minus 180, minus 360, minus 480, minus 720. Everything becomes 0. So here 180, 0, 0, 180, 360 like that. 180 means pi, 360 means 2 pi. Okay, 480 means 3 pi. So shall I write n pi? N is belongs to z. Substitute n is equal to 0. 0. Sine 0 is 0. Something by 0 undefined. So n is equal to 1 pi 180. Sine 180 0. Something by 0 undefined. So we have to remove that. So we have to eliminate all these values from the given real number. Shall I write like this? N pi, n belongs to z. Yeah. So what is the range? R. Real number. That's it. Okay. So the given input must be like without undefined value. So if you take, if you including this 0, 180, this is like that, it will become undefined. We don't want undefined value. We require defined value, right? Okay, fine. So this is the domain and range must be remember everyone. So what about secant x? Secant x nothing but 1 by cos. 1 by cos. So here, so what is the input we should give? Real number. What is the output we are going to get? Real number back. Here also secant nothing but secant x means 1 by cos x. 1 by cos x. So when cos becomes 0 for this values. So whatever the domain of tan, the same domain for secant, because tan nothing but sine by cos. Sine by cos. Secant also 1 by cos. Denominator is cos. Okay. So all these values cos become 0. So the x 2n plus 1 pi by 2. So what about output? Anyone? Can anyone say that what is output? The secant. Is secant lies between 1 to minus 1? Anyone? Is there any value
No, sir.
lesser than 1? Lesser than 1? No. Is there any value more than minus 1? No. So other than minus 1 to 1, because from minus 1 to 1 the secant inverse, secant x, cosecant x does not exist. Okay, so this can be written as r of minus 1 comma 1. This is also can be represent mod x less greater than 1. This is also can be written as minus infinity comma minus 1 union 1 to infinity. Okay, like that we can write in three ways we can write. You can write any one of the way. Either you can write r minus 1 minus 1 comma 1, or modulus x greater than 1, or else simply you can write like this. Okay, how to write here also? uh, this value also we can written as mod x lesser than or equal to 1. Mod x lesser than or equal to 1. Either you can write simply minus 1 to 1, or else mod x lesser than or equal to 1 in the sense same. Or also you can write like minus 1 lesser than or equal to x lesser than or equal to 1, minus 1 lesser than or equal, right? So all three cases are same. We can represent in these three ways. Here also we can represent in three ways. So here also these are the three ways we can represent. All will give same meaning, right? Next, the last one is cosecant. Cosecant x same or minus. Cosecant x nothing but what? 1 by sine. Like cot. Cot also cos by sine. By sine nothing but n pi ns belongs to z. Ns belongs. What is output? What is output? Secant cosecant will be same. The range will be same for secant and cosecant. Whatever the range I have written, the same range you can write. In some textbooks, sometimes they may represent the domain may be like this. Domain may be like this. Okay, sorry. Output. This is the output. Output may be like this range. Okay, maybe like this, maybe like that. Any one of the way. Can't remember. Okay, right. So if we draw the graphical representation, I think so already you know very well about the graphical representation of sin x, cos x, tan x, secant, cosecant. Yes or no? whether you know or you don't know graphical representation. Okay, so you should think very logically here. The function, without function, there is no calculus. Without functions, not, I'm not saying inverse only. Without function concept, there is nothing, no calculus. In calculus, each and every problem depending on functions. It may be e power x, it may be log x, it may be hyperbolic function, inverse hyperbolic functions, whatever it is. It is a function. Okay, but geometry is different. Circle, hyperbola, parabola, that is different. But calculus, completely depending on the function. Function nothing but for each and every function. Remember, domain is what? Range is what? Log x is there. What is the domain of log x? Log x domain is clearly this positive real numbers. Positive real numbers. Log does not exist at 0. Log 0 undefined. Log 0 undefined. Log does not exist for negative values. So domain input is infinite positive real numbers. What is output for the log? That is real number. How logic is there? If we draw the graph also we get like this. See, the range nothing but y values. Y value from minus infinity to infinity. Graph is existing from minus infinity to plus infinity. But what is the input? What is the values it taking? What are the x values it taking? Like, see, only positive side of x-axis. The graph does not exist in second quadrant, in third quadrant. Nothing but input should not be negative. Look at here. Graph is exist first and fourth. X is positive. Input is x values, output is y values. Remember that. Domain is always x-axis. So the range is lies on the y-axis. That's it. Okay, fine. I hope that everyone remember. Now let us see the graphical representation of sine x. Then if you understood that graph of sine x, then you can easily get the graph of sine inverse. Okay, right, sine. X-axis, y-axis, here it is 0. Okay, fine. On x-axis, I'm going to take a 90, 180, 270, 360. Okay, 2 pi. Okay, like this. See here, just now I have written already for sin x. What is the range? Yes, range is what? Minus 1 to
1.
plus 1, right? Minus plus 1 will be here, minus 1 will be here. Fine. Okay. We know very well that sine values. What is sine 0? 0. Sine 90? 1. Input is x-axis, output is y-axis. Sine 90 is 1. 1 nothing but y. Okay, right to 180. Sine 180 is 0. 270 is minus 1. And again 360. Again like this. Plus 1. 0. Minus 1. Like that. Even left side also. Sine minus 90. What is sine minus 90? Is it minus 1? Yes. Anyone? Is it minus 1? If it is minus 1, why? Why it is minus 1? Yes. Look at it. Sine of minus theta is equal to minus sine theta. We can write like this. Why we can write like that? Because sine is which? Odd function. So what are the even trigonometric function? What are the odd trigonometric function? That you should remember. So what are the even? Cos and 1 by cos, secant. Cos and secant are the only two functions are even. Nothing but if we write like a cos of minus theta, we can write plus cos theta because cos is a even function. Okay, plus cos theta. But remaining other than cos and 1 by cos, that is secant, remaining four trigonometric functions are odd functions. Odd function means sine of minus theta minus sine theta, tan of minus theta minus tan theta, cot of minus theta minus cot theta, cosecant of minus theta is minus theta. Fine, clear? Okay, fine. So if I take theta value as minus 90, so this is equal to minus sine 90. Sine 90 we know that 1, so minus 1. So the answer is minus 1. So minus 180, it is 0. Now minus of minus plus. See, sine 270 is minus 1. So minus already the minus of minus plus 1. So like that. Okay. Now we can join all these points or plot all these points by a smooth curve. By a smooth curve, we are going to get like this. Sine wave. You know already. Once again, we can revise. You know very well about this. So we are going to get a sine wave like this. See, what is the maximum value? The maximum value is this. These are the borders. It should not be cross the borders, right? Right. It should not be cross the borders. Minus 1 to 1. Okay, let's see. This is the sin x graph. Y is equal to sin x graph. So, but the concept of the chapter is inverse trigonometric functions. We should discuss about inverse trigonometric functions. And okay, right. First of all, we studied about what here? Vertical line test, horizontal line test. Two tests are there. Vertical line test and horizontal line test. So what is the use of vertical line test? Okay, for what purpose we can use vertical line test? For what purpose we can use horizontal line test? Do you have any idea? Did you remember or not? I explained you.
Sir,
The word, yeah,
the vertical line test is used to check whether the relation is a function, sir.
yeah. So given relation is a function or not. So further to check the given relation function or not, vertical line test. Vertical line test is nothing but what? You can draw the vertical lines from here. See here, the graph, if we extend like that, it will tends to up to minus infinity. If we extend right side, it will tends to plus infinity. So domain is what? From where to where the curve is exist minus infinity to plus infinity. That is nothing but R, real number. So that we are written here, the domain of sin x is R. Nothing but it will take x value minus infinity to plus infinity. Fine. So the range is minus 1 to plus 1. This is range. Okay, fine. That is okay. So vertical line, you can draw the vertical line anywhere from minus infinity to plus infinity. Anywhere you can draw. Okay, I draw like this. For example, I draw like this. So the vertical line, so touching or intersecting the given curve at most how many points? Yes. Any vertical line. Maximum at how many points?
1.
1 point. So when the vertical line can meet the given curve at most maximum at 1 point, we can say that the relation is function. Okay, if this is sin x, already we saying that sine function. So it is a function. Is it 1 1? My question is, with using the either vertical or horizontal line test, can you say that can you check directly whether it is 1 1 or not without checking the property like f of x1 is equal to f of x2, which implies x1 is equal to x2? That is mathematically, graphically. Can you tell me it is 1 1 or not? It is not 1 1. It is not one. How can you say that it is not 1 1? By using horizontal line test. Okay, you can draw the horizontal line. Horizontal line from where to where? Minus 1 to 1 only. Don't draw the horizontal line more than 1 because the curve does not exist more than 1. So it lies between minus 1. Okay, I want to take the horizontal line at y is equal to 1 by 2. Y is equal to 1 by 2. See here, y is equal to 1 by 2. At this point, I draw the Horizontal line. Horizontal. See, this line can meet the given curve at how many points? Yes, maximum at how many points it will be intersected? Students. Yes. Is it the horizontal line can meet at only one point?
No, sir.
More than one point. Am I right? So if the horizontal line can meet the given curve more than one point, it is not one. Okay, in this case, in the minus infinity to plus infinity, the sine x is not 1. The function which is not 1, it is not bisective. If it is not bisective, inverse is exist. Is inverse is exist? No, never. So then how can you define sine inverse x? The topic is that sine inverse trigonometric functions. We need to discuss about sine inverse, cos inverse, everything. But if we take here minus infinity to plus infinity, even it is not a 1, so sine inverse does not exist. Then what to do? Yes, what to do then? It is not 1. Clearly, we can say that inverse does not exist from minus infinity to plus infinity. So that we have to restrict that domain. Minus infinity to plus infinity is given. We can restrict that. We can take a finite interval. Finite. It is infinite interval. Minus infinity to plus infinity. So we can restrict that to the domain. Okay, so what is the domain of sin x? Sin x domain is what? Sin x domain is real number. We can restrict. See here, if you able to understand how to restrict that sin x domain, the same concept we can applicable for cos x, tan x, secant, cosecant, everything. Okay, if you understood this, you can easily understood that cos inverse, tan inverse, everything. Okay, fine. This is sin x. So I want to restrict nothing but, so I want to take some finite interval, not infinite. So let us see here. I want to take x-axis, y-axis. This is origin. Okay, x dash and y dash. Fine. I want to take minus 92 plus 90. What I have done? This minus infinity to infinity. I have taken just the interval from minus 90 to plus 90. I restricted that. So now what I want to do? So what is sine 0? 0. Sine 90 is what? 1. Here 1. Here it is minus 1. Sine 90 is 1. Sine minus 90 is what? Minus 1. So this graph only will get. Yeah, this is the graph of sin x from minus 90 to plus 90. So what is the use if we restrict the domain? Now can you tell me, if you draw the horizontal line, we can draw the infinite horizontal lines. Your wish. Draw this, draw this, draw this, draw this. Anywhere you can draw the horizontal line from 1 to minus 1. So whatever that are each and every horizontal line, at how many points it will be touching the given curve? Yes. At how many points? Maximum number of points, how many?
One. One.
1. Is it 1 or not? By using horizontal line test. Yeah, obviously it is 1. Okay. So if you use vertical line, every vertical line will meet, can meet the given curve at maximum 1 point. Horizontal will also meet at 1 point. Fine. Both the cases 1 point, it is 1 and on 2. So inverse is exist or not? Yes, it is inverse exist. Okay, so what is the inverse here? What I said in inverse function. If you define the function from A to B and inverse function F inverse from B to A, nothing but what? A is belongs to x-axis. X-axis, B is belongs to y-axis. Now B becomes belongs to x-axis, A becomes y-axis. Nothing but what to do here? Inverse function. It is simple. Okay, so what to do here? Domain becomes codomain. Codomain becomes domain. Nothing but what? So what are the values I am taking on y x-axis here? X-axis minus 90 to plus 90. So in inverse function, we should take on y-axis. So, so minus 92 plus 90, I am taking on y-axis minus 92 plus 90. So what are the values on y-axis here? In sin x, minus 1 to 1. In inverse, you can take on x-axis minus 1 to 1. Minus 1 to 1. Now again, what is sin 0? 0. What is sin 90? Sin 90. Sin 90. 1.
1.
Yes. Sin minus 90. Minus 1.
Minus.
Yes, sir. Right. Joining this 3 point by smooth curve like this. This is the required sin inverse x. So we have to restrict the domain, then only inverses exist. Then only it will be 1 1 and on to, otherwise if you take minus infinity to plus infinity, not. So is it possible only one interval like minus 92 plus 90? Not like that, not like that. You can take infinite subintervals. Infinite subintervals, like look at here. I want to take here, this is what, yeah, for example, I want to take here minus 90 instead of this 92 to 360. 92 360. What is the sign graph? 90. 90 means here. Here. Okay. Here. So this is 90. This is 360. So you can draw here. This is the graph of sine. In that case also it is clearly 1 1 and on 2. So draw the horizontal line, draw the vertical line. It will meet at one point. So that the sine x is inverses exist for 92 270. Not only that 272 450 also it will be exist. 452 720 also it will be exist like that. So like infinite subintervals are there. But in that we have to take a least value, the least positive, like least interval. What is the least interval which is belongs to both x and y axis? This minus 92 plus 90. So this interval, whatever the interval we are taking, that interval is called principal value branch. There are infinite branches are exist in that. It is 1 1. So you can take any loop like year to year. This is also sine graph 1 1 and on to. This is also sine graph 1 1 and 2. Like that, infinite subintervals are there. Infinite subintervals in each and interval, every interval, it is 1 1 and on 2. But we can take a particular interval, that is minus 92 plus 90, which is related to x axis, y axis. So this value is called principal value branch. Principal value branch. Remember everyone, what is the principal value branch of sine inverse minus 92 plus 90? Principal value branches belongs to domain or codomain or range. Yes, it is not belongs to domain. Principal value branch which is belongs to codomain. Nothing but output. The output is called principal value branch. Simply remember that. So input is minus 1 to 1 only. Input is x-axis. Output is y-axis. So output is called range. The range, whatever the range is there, that is called the principal value branch. Principal value branch. Okay, so finally the sine inverse is exist from, now I'm writing here the domain and range of sine inverse. Sine inverse of x is domain nothing but x-axis minus 1 to 1. The range, the output is minus 90 to 90. Okay, is it clear? Is it clear? Right. That is the domain, that is the range. This range is called principal value branch, PVB. PVB. Remember that principal value branch, PVB. Okay. Now let us see that cos inverse x, because if you understood this graphical representation, then everything becomes easy. Nearly 40 to 50 properties are there in this inverse. Okay, in that we require just for NCRT purpose 10 to 15 properties enough. But anyhow, I'll write all the properties, whatever 30 to 40 properties I will write. So you should note down. then how can we find that 30 to 40 properties, how to remember, then how to derive each and every property, that I'll explain you very clearly. Okay, this is very small chapter. If you start directly exercise, directly exercise, if you start, it will take just 2 to 3 periods, we can complete the chapter. Okay, for NCRT purpose, if I start directly exercise, the first exercise will take just 2 periods. The second exercise maybe 2 to 3 periods. Almost 4 to 5 periods we can easily complete. Okay, okay. I'm not started that questions are very easy. I'm telling you that whatever the questions they given in exercises that are very very easy. We can do directly. We can say direct answer also. What is the answer will come. We can say directly, no problem at all. But the most of the student they can confusing it. But graphical is important NCRT wise and especially OBT. OBT student you must be remember. Okay, coming to the cos. If you see the graphical representation of cos, right, this is 0 and same 90, 180 and 3 pi beta. I'm taking up to here only. So here it is minus 90, minus 180 and here it is 3 pi by 2. Okay, now cos also 1. Here it is minus 1. So cos 0 is 1, 90 is 0, cos 180 minus 1, 0, like that. Here minus 90 again 0 and minus 1, 1. Because cos is even. Cos of minus 180, cos 180, cos 180 minus 1, here also minus 1. So if we joining all this point by a smooth curve, we are going to get the curve like this. So this curve also exists from minus infinity to plus infinity. Again, by vertical line test, it is clearly function. But when you use horizontal line, it is not a 1 1. It is not 1 1. Again, we can restrict the domain, restrict to the domain. So from where to where we can take the domain here. So because it is even function, so that I'm taking the domain like this. X-axis, y-axis, I'm taking 0. This is 90 and 180. So, so 0 is 1. Okay, you should not take minus 90 to plus 90. It is not. If you take minus 90 to plus 90, it is not at all 1 1. So you should take like one loop like this. One complete loop. Cos 0 is 0, cos 90 is 0, cos 180 is minus 1. This. This is the cos graph from 0 to 180. 0, cos 0, 1, cos 0, 1. This is clearly 1 comma 0 comma 1. This is 0 comma minus 1. So right now for this it is clearly 1 1 and on to bisective. Then inverse also exists. Okay, what is inverse? This is y is equal to cos x graph. From where to where x belongs to 0 to pi. Domain is what? 0 to pi. Codomain range is what? Minus 1 to 1. So now cos inverse. Cos inverse is cos inverse x. I said very clearly, domain becomes codomain. Codomain becomes domain. X-axis becomes y-axis. Y-axis becomes x-axis. What are the values on x-axis? 0, 90, 180. We can take on y-axis 0, 90, 180. And what are the values on y-axis? Minus 1 to 1. Take on x-axis minus 1, 1. Now what is cos 0? 1. What is cos 90? 0. What is cos 180? Minus 1. Cos 0, 1. Cos 90, 0. Cos 180 is minus 1. So now joining this point by a smooth curve. Simple. Take x value of cos, you can take on y-axis. Y values take on x-axis. So this is the inverse. So what do you observe here? Cos inverse x domain is what? Domain means x-axis values. Minus 1 to 1. So what is the range? Range means y values 0 to 180. Here what is the principal value branch of cos inverse? 0 comma pi. Okay, 0 comma pi. Okay, 2 minutes, students. I'll drink some water. Is it okay, students? See here, my suggestion is if you are unable to understand the starting class, it is very, very difficult to understand next problems. Okay, the problem which is related to inverse trigonometric functions. If we able to understand the basic classes, this is fundamentals. Okay, so the questions becomes easy. Right, this is about cos inverse. Then what about tan? Let us see the tan. X-axis, y-axis, same 0, 90, 180, 270, that is 3 pi by 2, minus 90, minus 180, minus 270. Yeah, student, can you tell me what is tan 0? Tan 0. I'm taking minus infinity to plus infinity. Tan 0. Tan 0, 0. Okay, tan 90. Yes.
Infinity.
Yeah. See here, 0 is 0. When you comes to 90, it is tends to infinity. Like infinity. Minus infinity means what about tan minus 90? Tan of
Negative
minus
infinity.
s minus infinity means it will move to minus. Fine. See here. Actually, whatever I given like dotted line, this is called asymptotes. So the JEE student, you are going to study this asymptotes concept in IIT. Asymptotes means it is a tangent at infinity. So the line which can meet the given curve at infinite point. We are unable to draw the graph, but that tangent is called asymptotes. The tangent at infinity is called asymptotes. Okay, fine. So like this. Then what about, yeah, can you tell me tan is positive or negative in second quadrant? Positive or negative? 90 to 180, 90 to 180 second quadrant. Positive or negative?
Negative, sir.
Negative,
Negative.
negative, negative, nothing but the graph you should take down. And 180 to 270, third quadrant. Third quadrant, positive or negative?
Positive.
Positive, so that it will be moved to upside. See, we can easily draw the graph like that. Next, again, the loops. This is one of the loop. 90 to 270. 270 to 450. Again, one loop we are going to get. It will be repeat. Now, what about here? Same. Tan 180, 0. Okay, like that. So, here infinite loops are exist. Now, clearly it is function. You can draw the origin vertical line. Again, every vertical line meet the curve at most at one point, but whereas horizontal line again, it will meet infinite points. It is not one. So if we take the domain minus infinity to plus infinity, it is inverse does not exist. So again, we can restrict that domain. So we should take the finite interval. What is the interval you need to take here? Yes, I want to take just again minus 90 to 90. Minus 90 to 90. I'm not including plus 90 minus 90. Why should we not include? Because if we include that 90 means again it will tend to infinity. don't include. Okay, right? So you can draw the graph, we get like this. Is it clear? So it is y-axis infinity to minus infinity. Other than this, other than minus 90 plus 90. So if you see the graph, now is it 1 1? Draw the horizontal line anywhere. Every horizontal line can meet maximum at one point. So clearly it is 1 1 onto the inverse is existing. What is the inverse here? Inverse. This is tan x graph. Tan x graph from where to where? So x belongs to open interval 90 to 90. Remember that open interval 90 to 90. I'm not including that. What about inverse? I clearly said that x values becomes y value. Y value becomes what? X value. So y value is clearly this is plus 90. This is minus 90. So here plus infinity, minus infinity. So these are the borders. So here also these are the borders for the graph. It should not cross 90, minus 90 plus 90. So here we are going to get like this. See here, infinity. Tan 90 is plus infinity almost. Tan minus 90 minus infinity. This is the tan inverse graph. So now can you tell me what is the domain and domain means x values minus infinity to infinity. Okay, what about the range minus 90 to plus 90. Simply you can write real number also here. R. Instead of minus infinity to plus simply you can write R. Okay, so finally the tan inverse. So you should remember this principal value branch as well as domain. The mainly many questions are there. This principal value branch. What is output? Input is this. Output is what? In the same way, you can check that the secant inverse, cosecant inverse, cot inverse. Okay. Oh, sorry. Is it difficult to write that secant x and cosecant x graph? Nothing. It's very easy. If you know the sine graph, see here, I will tell you cosecant and you can remember sine we get like this 90, 180, 270, 360. Same here also minus 90. I'm going to explain you that cosecant x graph. So first we have to draw the graph of sine. Like sine x is like this. So it will be this is 1, this is minus 1. So again you will get like this. Okay, this is the graph of sine. So what is the border here? Border is maximum value of sine is 1. So minimum value of sine is minus 1, right? Minus 1. Then what about cosecant x graph? So this clearly cosecant x graph is that simple, yeah, yeah, this corner is you can start the graph like this. Yeah, what is this? This is there. So end point, this is should be same. So this corner you can up. So what about here? This is up. So now you can draw the, you can remove this graph of sine. This is the graph of cosecant x. Draw the sine, then after that at that corner point you can draw the loop of cosecant. Okay, like this. This is the cosecant x graph. In the same way secant x, first you can draw the graph of cos x. At that loop, each loop you can draw the loop upside or downside. Okay, like that. That is okay. And I'm going to write the principal value branch of cot inverse and everything. Cot inverse x same real number, but here it is 0 to pi. Secant inverse of x is clearly here r, domain becomes here r minus 1 comma 1, and the output is what? For that output is clearly 0 comma 180 minus 90, because I other than 90, other than why other than 90, secant 90 is undefined. Secant, I'm taking secant 90 is undefined, so that other than. So what about cosecant? Cosecant is r minus 1 comma 1, otherwise mod x is greater than 1. Here also mod x is greater than 1. Output is, so see here, secant is reciprocal of cos, both will be same. Cosecant is reciprocal of sine inverse, close interval, here also close interval, but other than 0, because cosecant 0, no, cosecant 0 is clearly undefined. Cosecant 0 90. Okay students, so like that you have to remember uh, principal value branch and of inverse functions, very 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 important. If I ask any moment any time, you should give the answer, right? You must give the answer.